Hi, my dear friends. Today I have come with one more problem on moment of inertia. So the question here is there is a circular disk lying in the first quadrant and a hole of 16 mm radius is punched out of it. The total radius of this circle is given as 44 millimeter. Then the diameter will be 88 and we have a circle or a hole which is punched out of it. The radius of this one is 16 millimeter, which is given to us. Now here we have to determine the coordinates of centroid for the given section as well as the moment of inertia with respect to its centroidal axis. Now for that, step 1, coordinates of centroid for the given section. Now let us assume that there is a point C1 whose coordinates are x1 y1 for the bigger circle, and let us assume that there is a point C2 whose coordinates are x2 and y2 for the smaller circle. Now as the radius of this one is given as 44 millimeter, then C1 will become 44 comma 44 millimeters, and C2 will be 44 plus 16. 44 plus 16, that will be 60 comma 60. The distance from here up to this particular point, right, it will be 60 millimeters. C1 will be 44 and 44 millimeter, whereas C2 is 60 and 60 millimeter. Now calculating the areas, area of the first circle, the bigger circle will be pi r square, which is equal to 6082 millimeter square, and A2 will be equal to 804.24 millimeter square. Now we have the formula to calculate the centroid. Capital C x bar y bar is equal to sigma AI xi divided by sigma AI and sigma AI yi divided by sigma AI. Now here sigma AI xi divided by sigma AI, that is x bar, which will be equal to A1 x1 minus A2 x2 by A1 minus A2. Similarly for y bar, A1 y1 minus A2 y2 divided by A1 minus A2. Substituting the values, the area of the bigger circle is 6082 multiplied by x1 is 44 minus 804.24 multiplied by the value of x2 is 60 divided by 6082 minus 804.24. Similarly, y bar will be equal to 6082 multiplied by, so we have y1 which is 44 minus 804.24 multiplied by, same thing again, 60 divided by 6082 minus 804.24. Now both the values will be equal to, so 41.56 and 41.56 millimeters. So capital C x bar y bar will be equal to 41.56 millimeters and 41.56 millimeters. So this is centroid. We got the first answer. The next thing is we need to calculate moment of inertia with respect to centroidal axis. So we have 41.56 over here. Suppose the point 41.56 lies over here, right? Let this be capital C. Let us assume that it is capital C. Now from point capital C, I'm just drawing a horizontal line. Now this horizontal line is representing capital X bar and X bar, or capital X and X, as well as let us draw a vertical line which is passing through the point C. Let us call this one as Y, whereas capital X and capital Y represent the centroidal X axis and centroidal Y axis for the entire section, whereas X1 Y1 represent centroidal X axis and Y axis for the bigger circle, and X2 as well as Y2 represent the centroidal X axis and Y axis for the smaller circle with respect to this particular reference axis. So we have the formula to calculate the moment of inertia with respect to centroidal X axis, that is sigma moment of inertia with respect to centroidal X axis for the bigger rectangle and smaller rectangle plus area multiplied by square of distance between both the axes. Similarly for y-axis, Iyy, which is equal to Iyy plus a into hx square. Now expanding the formula, we have Ixx1 plus a1 multiplied by hy1 square. This is for the bigger circle, minus Ixx2 plus A2 multiplied by hy2 square. This is for the smaller circle. Now expanding the formula for Iyy, here we have Iyy1 plus A1 multiplied by hx1 square minus Iyy2 plus A2 multiplied by hy2 square. Now here hy1, hy2, hx1 and hx2 are the distances between centroidal axis and the reference axis which is given to us. Now just look at over here, right? We have the capital Y and Y axis as well as Y1 and Y1 axis. Now the distance between these two axes can be taken as hx1. Similarly, we have Y2 and Y2 axis. This Y2 and Y2 axis, the distance from capital Y bar or Y axis up to this Y2 and Y2 axis can be taken as hx2, this distance. Now similarly, capital X bar and X bar as well as X1 and X1, the distance between these two axes can be taken as hy1, whereas we have X2 and X2 axis here, capital X and X axis here, the distance between these two axes, it can be taken as hy2. There is a very simple thing, right? Easily you can calculate hx1 and hx2 by using these formulae, right? Now here hx1 can be taken as difference of x bar and x1, whereas hx2 can be written as the difference of x bar and x2. Similarly, hy1 is the difference of y bar and y1. Similarly, hy2 is the difference of y bar and y2. Now substituting the values here, so we have x bar and x1, 44 minus 41.56. So here this one is x1 and we have x bar here. Similarly, x bar minus x2. So the difference between these two things can be taken as 60 minus 41.56. Similarly, for y bar and y1, we have 44 minus 41.56 and 60 minus 41.56. Of substitution and calculation, we got hx1 which is equal to 2.44 millimeter and hx2 which is equal to 18.44 millimeter. hy1 will be 2.44 mm again, and hy2 will be 18.44 millimeters. Now we know that moment of inertia of any circle with respect to its own centroidal axis will be pi d power 4 divided by 64. Now for the bigger circle we have the diameter that is 88 millimeter, and for the smaller circle we have the diameter d is equal to 32 millimeters. Now Ixx will be equal to pi d power 4 divided by 64 plus area of the first circle multiplied by hy1 square minus pi small d power 4 by 64. This is for second circle, the smaller circle, multiplied by a2 multiplied by hy2 square. Now substituting the values, we have the diameter capital D which is equal to 88 millimeters, and hy1 is 2.44, and hy2 we have 18.44 millimeters, and the small d which is equal to 32 millimeters. Now calculating the value of Ixx, we get Ixx which is equal to 3304897.987 millimeter to the power 4. So this is the first answer. Next, coming back to the next one, Iyy which is equal to the same thing again as Ixx is this particular value. We have hx1 as well as hx2. The areas and the diameters are same. Iyy will also be equal to 3304897.987 millimeter to the power 4. So these are the two answers. Thank you.